So, hello everyone. Thanks for joining virtually for this presentation entitled Conversational Recommender System based on Neural NLP Models. On this project, I'm working together with my colleagues from ITIA, Alessandro, Fabio, Vani, Denis, as well as our partners Marco, Lorenzo, Martino, founders of StageEnd, our InnoSwiss partner. So StageEnd is basically a booking platform for event organizers and entertainers, and they cover a wide range of events, as you can see here, backed up with a lot of different entertainers. So basically, this is an online recommendation platform where event organizers are playing the role of users and entertainers are playing the role of items. And basically, how does it work? So event organizer can describe their own wishes for the entertainment they want on the StageEnd website in the semi-structured way. And then based on the AI-powered booking agent, they're obtaining a list of possible entertainers which satisfy their needs, which they can then compare, check. They can ask for some additional information or pose some additional requirements. And after they make a choice, book, pay, and enjoy this fantastic entertaining experience, they can provide a feedback about the entertainer. And actually, Denis and Alessandro already worked with our StageEnd partners to develop a Bayesian approach for this solution. We are given every new piece of information using Bayes rule, the model is sequentially updated. To give you an illustration how this works, let's say that John is an event organizer, and we are questioning ourselves who is the best entertainer for John. If we have no prior information about the type of the entertainment that John needs, we will score each of the candidates with equal score. However, if we know that John wants to organize a wedding, then we can filter out certain entertainers, and we can update our conditional belief and update the ranking of different entertainers. So what I already explained is basically a conversational recommender system. And conversational recommender systems are a more sophisticated type of traditional recommender systems in the sense that user preferences are not all provided beforehand, but rather in an interactive manner. And if these interactions can be provided in a natural language form, then they are perceived even more user-friendly. So StageEnd already has different types of interactions in form of natural language. As I said, event organizer can ask questions and receive answers, and he or she can provide feedback in this free form. So basically, this is something which can be used. Now, the problem might occur if this new piece of information is incomplete or delayed. For example, what if I ask a question, but entertainer in this moment is very busy and cannot provide the answer? So what we are looking for here is actually to enhance these recommendations using NLP methods. That is to develop a component which is able to track and update the information itself. Because in some cases, the information can already exist, for example, in performance biography or in conversation from previous events. So we basically do not need to pose the same question again. And this is where question answering systems come into play. However, problem is a bit more challenging than it looks like. First of all, because we are working in the multilingual setup. So StageEnd operates in Switzerland and in some neighboring countries, and of course is always aspiring to extend its market to more and more languages, more and more countries, sorry. Hence, it is fairly understandable and expectable that event organizers and artists speak different languages. Here we have two options: to use one solution per language or to use multilingual model. Another challenge which we are facing with is that we have no ground truth whatsoever. Third problem is that same questions may have different formulations. For example, about pricing, I can ask, what is the total price, or is everything included in this amount, or how much should I pay? Fourth problem comes from the fact that similar questions, or apparently similar questions, actually might have different meanings. For example, we noticed when there is a temporal category, temporal component involved in the question, like, for example, could you play for 4 hours, or since when are you playing? These can be actually mixed and misinterpreted by question answering models. So what we tried first is simple BERT-based case model, which can handle only English language, and actually it does fairly okay with English text, if the answer exists in the text. Here, for example, you can see a biography of a certain band, which is based between Lugano and Zurich, and we are asking the question, where is the band based? And as you can see, the model output is Lugano and Zurich with the confidence of 90%, which is not that bad. Then we experimented with multilingual BERT, which has benefits that, of course, it covers different languages, so almost all our target languages. However, we obtained disappointed results even for English. So the text is still in English. We are asking still the same question, but we are asking it once in English and once in German. And as you can see, in both cases, the answers are pretty senseless. The scores, though, are very low, but it doesn't make the situation much better, given that the answers are completely useless. Then we tried with a multilingual fine-tuned model fine-tuned for question answering, and more precisely, we used exactly this model here, which is fine-tuned for 11 different languages, including English, German, and Spanish. So the fact that it was fine-tuned for Spanish makes it work very good for French and Italian, which we tested already. And it indeed provides fairly good results. So you can see here, again, the same text and the same question. When a question is asked in English, we are obtaining correct results, Lugano and Zurich, with a score which is not that high, to be honest. But then when asked in German, the answer is even more precise. We are getting the answer between Lugano and Zurich, and we are getting better score. However, then we faced another challenge in that when we combine all the text which we have for a single artist, single performer, which is typically biography, conversations, and these feedback or review, these models work fairly slow, even with the GPU. So based on some literature, we decided to perform slicing of this text based on the sliding window. And we experimented with a single artist text, which then was consisting actually of 5,456 short text and 1.5 million characters. And we posed a simple question: do you play songs of Ed Sheeran? And as you can see here, we experimented with different sizes of sliding window, different strides, which means offset. So for example, in this case, when we used a sliding window size of 100 words, this means that the overlap was, and the stride 80 means that the overlap between two different sliding windows was 20 words. And then, of course, number of windows is larger if the window size is smaller. Here you can say, you can see runtime, the score which we obtained, the answer, and this is simply the ID of the window where the answer was found. And you can see that the answers are fairly good, except in some cases. And actually, on the contrary to what was suggested by the literature, which was to take this fairly small window size and the stride equal half of the window size, the best results which we obtained were when there is no overlap between the windows. And when the window size was 2000. And then we are coming to as little to 1.6 seconds per answer, per question, yeah. Some additional observations which we saw when we tried to perform a language detection, because basically we wanted to distinguish between different languages to know which models to apply on which text. And we used for this LangDetect Python library. However, we encountered quite some mistakes and some unexpected languages as the output, since these texts are fairly short and we have different type of noise in them. For example, it can occur that we have named entities or URLs or stuff like that in English, and then the tool is actually biased toward English. Or simply we have some slang and abbreviations. Or we have also problems with Swiss German, which was misinterpreted in different cases. So this is obviously work in progress. So we are currently trying to find a way to make our partners use this for their production system. And for that, we are considering some offline pre-processing of text and offline question answering for at least static questions, so questions to which answers are not likely to be changed that frequently. However, it's pretty complex setup, and it depends a lot on the type of questions which have been asked. So we will probably need to apply different strategies and to spice this up with some heuristics. So I would like to thank you for your attention, and I can take some questions, and of course you can also write if you need additional clarifications. Thank you.